Hi everyone, this is Ray, Head of Engineering of HeyGen. Today I'm going to talk about one of HeyGen's products, real-time avatars. At HeyGen, our mission is to revolutionize content creation by replacing traditional cameras. Next, I'm handing over to Joshua, CEO of HeyGen, to introduce what HeyGen does.
HeyGen is an innovative AI-driven platform designed to simplify video creation, delivering results 10 times faster. Choose from over 100 pre-designed avatars or craft your own. Simply provide a script and watch as our AI swiftly produces captivating videos. Boasting over 300 voice options across 40+ languages for accurate lip syncing, it effortlessly bridges the gap with international audiences. There's no need for video editing expertise, making HeyGen ideal for marketing, sales, training, and onboarding initiatives. Its enterprise-grade features guarantee smooth collaboration and strict security adherence.
Thanks, Joshua, for introducing HeyGen. By the way, this video is AI generated. He's not actually here with me. If you are wondering what problems we're solving at HeyGen and what system we have built in order to generate such kind of video content, please follow me during this presentation. Today, I'm going to provide you more context of HeyGen first, and next, I'm going deeper into the architecture of the systems we have built, and last, we'll give you an overview of everything we have present today and what we are building for the future. So as you can see, there are a lot of video problems to solve in HeyGen. So the first one is avatar videos, as you just see. They can be used for internal training videos and also used for the marketing videos. We can also generate this kind of personalized video messages massively with our APIs. There are some other great features we built. For example, the video translation. So for example, if you are a YouTuber in English, but you want to reach more audience in other areas, for example, Spanish, also you maybe some reach the audience in the Asian countries, you can simply upload the videos to our platform, and our platform can translate your videos into other language with our Gen AI capabilities. It will provide perfect voice clones and also the lip sync. Last, we provide our real-time avatars capabilities. With this feature, you can build a virtual assistant for your customers to communicate them in real time. So this is a demo video, which is the same video as the previous one, but speak in Japanese. And this is generated by our video translation feature.
AI がビデオを作成します。40以上の言語で300以上の回の
Yeah, but today, what I'm going to cover is our real-time avatar product. So first, what is actually a real-time avatar and what it can be used for? So a real-time avatar is a virtual avatars that you can communicate with in real time. You can ask him or her questions, and you can also use it for the some other use cases. For example, you can use it for as the interactive e-learning, video conference, and also customer support. Next, I'll show you a demo which is built on top of our real-time avatar APIs. Here,
Hello.
I'm communicating with these virtual avatars. I'm asking her questions, and she can reply to me in real time.
Tokyo is the largest city in Japan.
Cool. Yeah, if you are wondering how we build this system and what challenges we are solving, please follow me to the next section. So next, I'm going to talk about the architecture of the whole systems. So our real-time avatars system is built on top of a WebRTC, which is a real-time P2P communication protocol. There are three main components in our system. The first one is a signal server, which is used as a WebRTC signal channel. And next, we have a WebRTC streaming server, which is the servers connected with client directly to deliver WebRTC streams to the client. And the last, which is the most important component of our system, is the GPU workers, which is to do the AI inference to generate AI avatar videos. So the big challenge of the system is that like, how can we make the machine learning model inference fast enough to ensure real-time experience? Next, I'm going to talk about like some key objects of our system. First one is session. A session is just an abstraction of WebRTC connection. In addition to that, it also provides like more information related to our system. For example, the avatars and the voice. So because our system can actually support different types of avatars and voices, you can pass whatever like avatars you want to use and whatever voice you want to use if our system support. And also, you can adjust the video quality you want. You can change the video resolution, sort of stuff. For the session, we actually have 5 states. First one is init state. When you want to start sending the real-time task to our system, you have to create a session first. After creating the session will put into an init state. And next, you want to establish the WebRTC connection with our servers. So in this case, you can call the start APIs, and then our servers will try to establish a connection with the client. In this case, it will be in the connecting state. But after the connection is established, it will be put into an active state. After all the tasks are done, the customer can choose to close the session. So he can call the close APIs of our service, and then the session will be put into closing state. During this state, our server will try to clean up the resources. After all the resources are cleaned up, it will put into the closed state. Another key object of our system is task. So a task is just a real-time inference task, usually like containing a text the client wants our avatar to say. So currently, we only support text input, but in the future, we might support some other input format. For example, audio. We might also want to support audio streaming and text streaming data. As I said earlier, our system consists of 3 components. The first one is signal server. So in addition to act as a WebRTC signal channel, it also provides some external APIs. So it has 4 APIs here. One is the new API, which is to create a session. A start API, which is used to tell our server that we want to establish the WebRTC connections. Then our servers can provide the ask offer to the client for the client to answer those offer. Then we provide these stop APIs to stop the session. And last, we provide these sending task APIs, which for the client to send a text to our server to generate the AI avatars. This signal server is also used to manage all the sessions and tasks in our system. It has a global view of how many sessions one server is handling and how many tasks a worker is processing. Next, I'm going to talk about the worker, which is the most important part of our system. So the worker is a component which is to do the machine learning inference to generate AI avatar videos. So usually the task in the worker is executed in steps. The task is divided into 5 steps and executed in a pipeline way. Firstly, it tries to pull the task from the signal server. After getting the task, it converts the text into audio using our text-to-speech capabilities. Then we segment the audio into smaller segments, like 3 or 5 seconds. Then we feed the segments into our machine learning models to generate the avatar videos. After the video segments are generated, they are streamed to the WebRTC streaming servers. And that server is responsible for delivering those videos to the client. All these steps are executing the different steps concurrently, which can provide a better performance. Another optimization we do in this service is it's called session stickiness. Some background about this is that so because our system can support different avatars, but different avatars actually have different artifacts and different model parameters. So in order to support different types of avatars tasks, we have to swap the model parameters out from the GPU memory and feed in new parameters. But one fact is that the GPU and CPU data transfer is really slow, which can become bottleneck of our system. So one optimization we do is that we actually make one session stick to one worker, which means that if a customer is continuous sending the task to our service, that model parameters will always live in the GPU. The next optimization we do is that we actually implement a tiered cache to improve the data transfer performance. As I said earlier, the GPU and the CPU data transfer is very slow. So we implemented a 5-tier cache to reduce this overhead. The first tier is the GPU model, which always live in the GPU memory. The next tier is called pinned memory. So pinned memory is a special area in our RAM, which it doesn't swap the data to disk, which makes it much faster than the normal RAM. So next tier is the normal RAM, and then the local disk. And last is the remote cloud storage. In this case, we use S3. Yeah, another optimization we do is called prefetching. So if a customer or if a client calls the start session APIs, it usually means that it definitely will send tasks after this call. The connection exception will take some time, right? So at the same time, when the client calls this API, actually what we can do is that we can ask our workers to download the model parameters and artifacts immediately. When the client starts to send that task, the model is already there. So we can minimize the network cost in this case. Next, I'm going to cover the streaming server of our system. So the streaming server is a very simple service. It just is connecting with the client and keeping the WebRTC connections. They provide one single WebSocket endpoint to receive the video data from the workers. There's no business logic at all. One reason we do this is that if there are a lot of business logic in the service, we probably will end up with deploying the service very frequently. But we don't want to do that because it keeps a connection with the client, right? So if we do deploy, we have to handle all this reconnecting, which will provide very bad experience to the users. Another benefit of this is that in the future, we might support other types of workers. If all the workers can just respect the WebRTC endpoint protocol, which it will make the integration really easy. For example, in future, we might support the CPU inference workers and maybe some other types of avatar, for example, photo avatars. Yeah, I have covered everything about our systems. Next, I'm going to talk about some other exciting stuff we are building for real-time avatars. First, as I said earlier, we're working on audio streaming and text streaming. So with audio streaming capabilities, the users can use their own text to audio service and streaming those audio data to us. Also, they can probably just talk through this channel directly and sending their voice directly to our service and let the avatar speak what he speaks. Secondly, we are working on the text streaming. I think one very popular requirement is that some customers want to integrate our real-time capability with ChatGPT streaming APIs. But ChatGPT streaming APIs very slow if it waits for all this text to be generated. So if we can support text streaming, the customer can actually stream those texts to our APIs. And while the ChatGPT is generating the text, the avatar can speak at the same time. We're also working on improving our inference performance. One thing we're doing is that we are trying to make our machine learning model run on CPU. Although the quality might not be as good as the GPU inference, but it's much more scalable because currently it's really hard to get a large amount of GPUs. but with CPUs, we can scale this capabilities to more hosts and serve more customers. And lastly, we are working on the SDK, because WebRTC is actually a very, very complicated protocol. Some customers really struggle to use. So if we develop some SDKs that can help the customer integrate with our AI capability much easier. So if you are interested, we provide our beta testing link here. So these APIs are still in beta. If you want to test, you can simply provide your information in this link, and we can have you join our beta testing. I also linked the API docs for you to integrate with our API easily. In addition to real-time avatars, we are also working on some other great features on top of our avatar capability. First one is called video translation business. We want to bring our video translation to the next level. For example, we are providing the proofread capabilities, which means before generating the video translation videos, you can actually edit the translated text to provide more accurate result. We also provide 4K output and longer durations. We're also working on the multiple speakers features for the video translation product. So next thing we're working on is called realistic avatars. So it's a feature for everyone who wants their avatar to generate videos. So the users can just upload a 30-second video clip to our system, and after 5 minutes, you can get a custom avatar used for video creation. Cool. That's all I have covered today. If you have any questions, feel free to reach out to me. Thanks.